Alright, topic 4, three-phase induction motor. Now this topic is a very big topic, just like the transformer is a very big topic, and we are going to divide our video clips into a few parts, okay, maybe 3 parts. Now induction motor, as the name suggests, is a motor but it's an AC motor, okay? Unlike topic 2, you learn DC motor, right? So now we are learning AC motor. Now AC motor is usually quite big and is used in, like say for example, the crane, lifting the container and things like that. Okay, so it's a very powerful motor. Now, to learn well in this topic is that it's very formula intensive. This topic has lots and lots of formulas, and some of them are provided in the exam, some of them are not. Right, so you must pay attention to those formulas that are not given, and if they are important, when you do it often enough, you remember them. You remember them. Okay, what's the working principle of induction motor? Now, induction motor, as it says, it is about current carrying conductor, right, react with magnetic flux and produce motion. Okay, same. It's the same principle. It's the same principle as the DC motor. Okay. All right. Now, how is it that what is the principle of physics behind it? Now, just like any DC machine, you have stator. You also have rotor. Right? Stator is the part that doesn't move. Rotor is the one that moves. Now, this time instead of supplying DC, alright, we are supplying AC, three-phase AC supply. Now, three-phase AC supply going through the coil, so that produce three-phase, right? Three-phase sine wave, and magnetic flux is therefore being produced. And this magnetic flux will travel around, they say, stator with a speed, right? The magnetic flux, and this magnetic flux is pulsating just like a sine wave, right? It's a three-phase magnetic flux, and it reacts with the rotor. Now, magnetic flux react with the rotor will produce. This magnetic flux is a moving magnetic flux. React with the rotor, so therefore it produces current. Okay, so it produces current. So the conductor in the rotor now has current. Right, so current carrying conductor in the rotor react with the magnetic flux will make the rotor turn, and that's the working principle of induction motor. Now, induction motor comes from the word induce, right? Induce EMF. Okay, where is the EMF induced? Here. Okay, I repeat one more time. How does it work? Stator is the part that's not moving, but we attach a coil, a three-phase coil to it, supplying three-phase AC power supply, and therefore it generates three-phase magnetic flux. And this magnetic flux traveling at a speed in the stator, and across the air gap. Here's the air gap, right? Cutting the rotor. Rotor is a bundle of conductors, and with that, current is therefore produced in the rotor, right? And therefore, the current carrying conductor in the rotor in turn react with the magnetic flux and produce motion. Okay, so the principle throughout EMD is always about this electromagnetism: current, motion, and magnetic flux. Alright, the first formula that we want to introduce is called synchronous speed. Okay, synchronous speed. And we use Ns to represent synchronous speed. Okay, Ns is equal to 120 F divided by P. Okay, and the unit for synchronous speed is RPM. Alright, F is the frequency of my AC power supply, and P is the number of poles. Right? Synchronous speed is equal to 1 to FOP. Now, what is synchronous speed? Remember just now I said about the magnetic flux that travel around in the stator. That the speed of this magnetic flux is called synchronous speed. So in other words, synchronous speed is the speed that you cannot see, your human eyes cannot see. Right? Okay, the second formula is called the rotor slip. The second one is called sleep, sleep. Right, sleep is equal to ns minus nr divided by ns. Right? Now what is nr? nr is the rotor speed. So sleep is the measurement of the difference between the synchronous speed and the rotor speed. Now rotor speed is the actual speed of the motor. Right? Remember I said this is the stator that is not moving, and rotor is the one that is moving. Right? Rotor is the one that is moving. So the rotor speed is the actual speed that human eyes can see. Alright? So sleep is a measurement between the difference of the magnetic flux speed which we call the synchronous speed versus the rotor speed. Right? So sleep is equal to ns minus nr over ns. Synchronous speed 120 FOP, rotor speed, the actual speed. Now, the actual speed of the motor can never be higher than the ns, cannot be more than the ns, because it's the synchronous speed that produces the rotor speed, right? And they are roughly the same. The values are very close. Example, if say for example this is 2000 RPM, right? This one could be like 1890 RPM. Okay, they are very close in value. Next, rotor speed can be calculated if you know the sleep and you know the synchronous speed. Right? nr is equal to 1 minus s multiply ns. Okay, if you know the synchronous speed, you know the slip, which is this slip, you can find the rotor speed. Fourth, frequency. Frequency is equal to s times f. Now, the rotor is the rotor that is moving, right? The rotor is moving, and the voltage produced in the induced voltage in the rotor, okay, is therefore an AC voltage, and therefore it has a frequency. So we say the rotor frequency is equal to S times F. Remember, S slipped, F is the frequency of the AC source, which is usually 50 Hz. Right? Are we okay with these basic four formulas? Let's pause for a while and take a look again. Synchronous speed is 120 F over P. Slip is ns minus nr over ns, and rotor speed is 1 minus s multiply ns, and fr is equal to s times f. Right? Let's work on a simple example to illustrate these four formulas. Okay. Alright, say example. Right, this is a 4-pole synchronous generator. Four-pole, 50 Hz, 3-phase. It's running on a load with a slip is equal to 4%. Okay, part A. Calculate the synchronous speed. Right, synchronous speed, what's the formula? 120 F over P. Right, so it's 120 multiply 50 divided by 4. What's the unit? RPM. Okay. Part B. Find the rotor speed. Right, rotor speed. And rotor speed, the formula is 1 minus S multiply NS. Right? And the slip is 4%. 4% means what? 0.04. This 1 minus 0.04 multiply the synchronous speed that we obtained above. Alright? Here is 1005. Okay, times 1000. So the answer is 144 OR. Okay? Part C. Find the rotor frequency. Part C, find the rotor frequency. Okay, rotor frequency means FR. And you still recall the formula? S times F. So it's 0.04 multiply 50 Hz. And that gives us the value of 2 Hz. Alright? Okay. Right, let's look at another example. The nameplate of a three-phase induction motor indicates 230 volts, 20 kilowatt, 50 hertz, and 1400 RPM. Right? Part A. Find the number of poles. Find the number of poles. Now, if you recall, to find the number of poles, there's only one formula that involves with pole, which is what? Ns equal to 120 F over P. Am I right? So in this question here, you're asked to find P. In the information given in the question, we have the frequency, which is 50 Hz, and we are given the speed 1400 RPM. Now this speed is what speed? It's actually NR, the rotor speed. So in this question here, we do not have NS, but we will assume that NS is equal to NR first. Assume first. Do you know why? Because they are very close. Remember what we say is very close. So when you need NS and you do not have, you always assume your NR to be equal to NS first. Alright, so we assume. So 1400. Right, so we assume NS equal to NR first. Yeah? So 1400 equal to 120 multiply 50 over P. Right, so P you get the answer, let's say it's 4.2. Right? Number of pole cannot be a fraction, so you must always round down. Right? So therefore, the number of pole is equal to 4. You don't round up, always round down. Okay? So that's the way to find the number of pole for this question. Part B. Find the synchronous speed. Formula again, 120 F over P. Right? So 120 times 50 divided by 4. P is 4, you got 10, right? So we get 150. Okay? And part C, find slip. Slip is equal to what? Ns minus Nr over Ns. Alright, so that is equal to 1500 minus 1400 divided by 1500, and that gives us 0.067. Slip has no value, no unit, sorry. Right, part C. Right, part D. Find the slip at full load. Slip. What's the formula? Ns minus Nr over Ns. Yeah? Ns is 1500, Nr is 1400, Ns 150. This one is given in the question. Ns is the one that we just calculated. So slip is equal to 0.0. Oh no, slip calculated already. Oh, I'm repeating. I'm sorry. Part C. Now part D. Find the corresponding frequency of the rotor voltage. Find the frequency of the rotor voltage. Formula S times F. S is equal to 0.067 and frequency is 50, so that's 3.35 times. Okay, and lastly, actually this question is from your tutorial. You're asked what's the output power. No calculations needed. He's just training you. We are just training you how to read question. When power is given is the output power. So that's 20 kilowatt. Okay, so that's the first section of the induction model.